Without question, the world is beginning to go green. Today, more than ever, there's a real push to find the best suitable energy sources. And if you've been paying attention, then you know that one of the cornerstones of the green movement is to find really efficient batteries to help store energy. So what's the solution? Well, researchers here at NASA Glenn Research Center have improved on an old idea, using a mechanical battery or flywheel instead of chemical batteries as an energy storage system solution. Yeah, and many here think that this new system is going to be a game changer in energy storage. So Ralph, first off, what exactly is a flywheel energy storage system and how does it work?
Well, a flywheel energy storage system is based on a really old concept. It's sort of like a pottery wheel where a potter would use the wheel, put energy in it by kicking it, and then as it spins, energy is coming out as he works. Well, we're doing some concept like that, but with a lot more sophisticated features. And this toy is a little bit of an example of some of the things we're doing. You can see this is magnetically levitated.
That is really cool.
Right. So it's floating in the air. And this blue section is the flywheel that stores the energy. When I spin it with my fingers, I put energy in there. And if I grab it, pull energy out. Well, what we're doing here at NASA is taking this to a really higher level by using sophisticated controls and materials to store a lot of energy in a very small amount of size and weight.
So we're basically talking about an energy storage device, like a battery. How is this different than chemical batteries?
We're fundamentally different in the way we store energy. It's stored mechanically, which a battery stores energy using chemical transformations, and that's sort of why a battery wears out after a year or 2 years or 5 years. What we do is we store energy by what's called kinetic energy in the rotating mass. And so we are able to build a system that survives for a lot longer time because all we have to do is make sure the wheel will stay together for a long period of time. And like I mentioned, we use magnetic levitation. So another problem with a mechanical system frequently is the bearings. You know, on your car, maybe the ball bearings wear out.
Sure.
Well, we don't have that problem because we use this magnetic levitation. So there's no friction, no wear.
Right.
So the systems we're building at NASA last 15 years, which is one of the main features that are good about this technology. Another one is that the way we transfer our electrical energy in and out is with a motor. Motors are a very old technology, 100-year-old technology, and they can be made very large like they do at a power plant. So this kind of technology, it's very easy for us to do extremely high power without any impact on our life. I don't know, you may have seen with your hand tools or your iPod, if you charge and discharge them a lot, then the battery doesn't last as long.
Right.
That won't matter to this.
Flywheels, they've been around forever, right?
Right.
Okay, why is it just being recognized now?
So flywheels have been evolving over the last 30 years, and what's special about the things that are happening now are that we're able to apply advanced materials and all these innovations that have happened in computers to make the flywheel store more energy and less weight and volume, and to operate in the same way that a battery can. The technologies that have been developing in the last 20 years in materials and vacuum systems, computers, power electronics, turn into a lot more compact flywheel than what you could build 10 or 20 years ago. NASA is using flywheels for space applications, and there's a few different ones. Satellite systems can use flywheels because we can do energy storage and momentum control. And right now, those functions are accomplished by batteries and momentum wheels, which can wear out. For example, on Hubble, the servicing mission, they've replaced the batteries 3 times, and they've also had to replace the momentum wheels. So that's why something like this, which does all those functions and can last 15 years, really is relevant for NASA satellites. Another NASA area is for our exploration effort. We're talking about putting bases on the moon and Mars. And a base on the moon or Mars would probably have solar array fields to give them power. But the power varies during the day.
Sure.
And you use energy storage to level that out so that you have power when you need it.
Nice.
So those are some of the things that NASA can use this technology for.
So wait, let me get this straight. This is an energy storage system, right?
Right.
It doesn't create energy?
No, that's right.
Right.
Some people get confused by that and
Yeah.
think we're creating energy here. This is like a battery. All it does is store energy.
Got it.
So we get electric energy from wherever we can, and you put it in here and you store it, and then you can use it later.
Store it indefinitely? I mean, and to what kind of capacity can you actually store energy?
The amount of energy you can store depends on the size of the flywheel.
Oh.
Flywheels are good for large amounts of energy storage, at least the size of a car battery or bigger. The system that we've built here
Yes.
is made for NASA, and we need to store energy for 90 minutes because that's what an orbit around the Earth is. So
Okay.
we actually charge it up for 60 minutes and then discharge for 30 minutes. It's running the spacecraft.
Hey Ralph, this was great. Thank you so much for having us today.
Thanks, really appreciate it, NASA 360 getting the word out.
No worries, man. Thank you.
Great.